Hi, today we're going over section 5.3, which is coterminal angles. So just a review from yesterday or last class, when measuring an angle in standard position, we always measure in a counterclockwise direction. So that means, for example, if I have this coordinate grid and a terminal arm, say here, then I would measure off of a starting point going counterclockwise to get a positive angle. So for example, 110 degrees. Or if I went in the opposite direction, that would give me a negative angle, which in this case would, if I went the other way, would be negative 250 degrees. Now, what we'll be going over today is coterminal angles, which are two or more angles that have the terminal arm in the same position. So for example, if we use that same angle as I did on the last one of 110 degrees, then that negative angle would also be considered coterminal, the negative 250 degrees, because it's in the same location. Or alternatively, we could go around the circle more than once and to our line. So that would be 470 degrees. Now you'll notice that all these angles are 360 degrees apart. So to get our coterminal angles, we add or subtract 360 degrees. Which leads us to this example: determine the measures of all angles in standard position from 0 degrees to negative 1200 degrees are coterminal to 280 degrees. And we want to sketch all these angles and write a general expression for all angles coterminal to 280 degrees. So first thing I would do is take my angle of 280. We're going from 0 to 1200, so negative 1200, so there's no point in adding to this, so I'll just subtract 360 from it. So that gives us negative 80 degrees. So if I draw that out, negative 80 would be approximately here. Now to find my next coterminal angle, I'll take that angle that I had, the negative 80, subtract 360 from it, and that gives me negative 440 degrees. So the terminal arm will be in the same location as the previous example, or sorry, it's previous angle of negative 80. So we'd have negative 440. So we'd go around once, and then we'd have negative 440. Our next angle, we'd go negative 440 degrees minus 360 degrees, which gives us negative 800 degrees. So for this one, we're going around once is negative 360, twice is negative 720, and negative 800 takes us to our terminal arm. Our next one, we've got negative 800 minus 360 gives us negative 1,160 degrees. So this one, we will go 3 times around before getting to our terminal arm. So once around gives us negative 360, twice around gives us negative 720, 3 times around gives us negative 1,080, and then getting to our terminal arm is negative 1,160 degrees. Now our principal angle is an angle between 0 and 360. So if we're given a list of coterminal angles, our principal one would be the one that's between 0 and 360 degrees. So for example, determine the principal angles for 1203 and 865. So with both these, we will just subtract 360 until we get an angle between 0 and 360. So first time I subtract 360 gives me 843. 843 minus 360 gives us 483. 483 minus 360 gives us 123 degrees. So the principal angle for 1,203 would be 123 degrees. For the next one, same thing. So we subtract 360 degrees. So 865 minus 360 gives us 505 degrees. 505 minus 360 gives us 145 degrees. So 145 degrees would be the principal angle of 865. Okay, so determine exact values of trig ratios for 1,035 degrees. So whenever we're given a very large angle like this, what we'll want to do is find its principal angle before we start solving. So I have 1,035 minus 360 gives us 675. We'll take that and subtract 360 from it again. And that gives us 315 degrees. So now we can draw out where 315 degrees would be. So 315 degrees would be here, which would give us a reference angle of 45 degrees. Now, if you remember your special triangles, that means each of these sides is 1. Now, this side is below the axis, so it's a -1. And our hypotenuse should be the square root of 2. So our three trig ratios are sine, which is our opposite over our hypotenuse, would be -1 over root 2. Cos, which is our adjacent over our hypotenuse, is 1 over root 2. And tan is our opposite over our adjacent. So -1 over 1, which gives us -1. Okay, next example, given that sine theta is -5 over 13, determine the other trig ratios for angle theta and determine all possible angles between 0 and 720 that this ratio works for. So for this, we will use our cast rule. So if you remember for cast rule, we start writing cast in quadrant 4 and then work our way counterclockwise around. Now sine is positive in the first two quadrants, which means it's negative in these two. So I'll draw out two separate coordinate grids, one with an angle in each of those quadrants, and we'll figure out our overall angles for each one of those. So first thing we'll do is solve for a reference angle. To get a reference angle, we will use our sine theta is equal to -5 over 13. When getting our reference angle, we don't need to use a negative. So we've got theta is equal to sine -1 of 5 over 13. So that gives us a reference angle of 23 degrees. That's going to be 23. That's going to be 23. And we can get our overall angle for this one by going 180 plus 23. So that is 203 degrees. For this one, it's essentially 360 minus 23. So that would be 337. Now, each of these will have a corresponding angle to them that is less than 720. So we'll also go 203 plus 360. So that gives us 563 degrees. Now we'll do 337 plus 360, which gives us 697 degrees. So we've actually started with the second part of this question. We'll do our first part now, which is determine buffer trig ratios. So sine was -5/13, which means that this side's -5, this side's 13. We can use Pythagoras. So we're using c squared equals a squared plus b squared, but rearrange that to solve for b. So we've got c squared minus a squared equals b squared. So 13 squared minus -5 squared is equal to b squared. So that gives us 144 is equal to b squared. Take the square root of both sides and we got 12 is equal to b. So this would be a -12. This would be a +12. Which means our trig ratios would be slightly different for our angle. So for this one, cos is our adjacent of -12/13, and tan would be our opposite of -5/-12, which reduce the negatives cancel out. So it is 5/12. For this one, cos is going to be +12/13, and tan would be -5/12. Okay, so practice work starts on page 445.